Hello there! Now you may be wondering, what is so fast about a camera? Well, I'll show you. When you take a picture with a regular viewfinder camera, you're not actually looking down the same lens that's taking the picture, you're looking down a separate viewfinder lens. And in some situations that gives you a slight difference in perspective because it's only an approximation of what your picture is going to be. Now a way around that is by using an SLR camera, which stands for single lens reflex. And that's pretty much exactly what it is. There's only one lens, there's no separate viewfinder lens. Now that requires a little bit of cleverness behind the lens. There's actually a mirror placed at 45 degrees that blocks the sensor, which means you can look through the viewfinder, down and through the exact lens that's going to take the picture. So that leads us on to the very fast part. When you take a picture, you'll hear this sound. Didn't sound like much, but actually quite a lot just happened there. And you'll notice that in the viewfinder, your vision was blocked for a very split second. So the only way we're going to see what actually happens is by taking off the lens, zooming the phantom in, and filming this at a ridiculously high frame rate. We'll start with a 30th of a second. Now you're looking at the mirror, which is in front of the shutter. When I press down the button, the mirror flips up out of the way and temporarily blocks the viewfinder. Then the shutter comes down, whoosh, now light is exposing on the sensor, and then the shutter closes again, followed by the mirror coming back down so you can see through the viewfinder again. As you can see from that clip, this camera has a mechanical shutter that moves out of the way and allows light to hit the sensor. A very fundamental part of photography is the duration of your exposure. It has very different effects on the image, and you can control that with the shutter speed. For example, a relatively long exposure of say 2 seconds would give you a bright image, but anything that moved within those 2 seconds would have a trail of motion blur behind it. So not ideal for filming a fast-moving subject. For a very fast-moving subject, you would want a much shorter shutter duration. The fastest this camera will do it is an 8,000th of a second, which looks like this. So now what we'll do is we'll use the phantom to film different shutter speeds of the camera and see how they all compare to each other in slow motion. Honestly, these are probably going to look identical in real time, but we'll definitely be able to see the difference in slow-mo. So we'll start with a 500th of a second. One thousandth of a second. A 2,000th of a second. 4,000th of a second. And an 8,000th of a second. Let's have a look at the 4 fastest ones side by side just to see the comparison. This kind of stuff is fascinating to me. It makes me wonder how many people take for granted what's happening inside that camera when they take a picture. The fact that the shutter is made of 2 clusters of metal blades that at their shortest duration are moving right next to each other, allowing just the smallest slit of light to hit the sensor. This is also a great visual representation of why you need so much light for a high shutter speed shot, because the amount of time the light is hitting the sensor is so short, you end up with a much darker image. There are many types of shutter that a camera can have. This is a mechanical shutter, but there's also an electronic shutter which doesn't have any moving parts. In video mode, this will actually use an electronic shutter. It basically takes an image 30 times every second without covering the sensor. This camera's shutter is also a rolling shutter, which is the opposite of a global shutter. And what that means is that it doesn't actually take the whole image at the same time. You may have noticed from the slow-mo that the image is taken from the top to the bottom of the sensor. That basically means that whenever you take a picture, the top of the picture is actually older than the bottom by a fraction of a second. And technically that statement should be flipped, as everything traveling through a lens is actually upside down by the time it gets to the sensor. The electronic shutter on this camera, when it's in video mode, works in the exact same way. It takes each line of pixels from top to bottom because it doesn't have the power to take the whole image at once. And this can lead to some interesting artifacts when filming certain subjects. You may remember this video from a few years ago. I was blasting Dan in the face with a cork, and when I was editing the video, I noticed something really weird in the Canon footage. On this one frame of video, the cork is suspended in the air, but the shadow of the cork has already hit him in the face. Luckily we had the Phantom right by its side so we can analyze exactly what happened with the Canon there. So imagine the color going down the screen as the Canon acquiring each frame of its video. Nothing happening in this frame. Watch this one though. As it gets down to the cork firing, it then hits the shadow. And that explains why there are two different moments in time at different heights in the same frame. Almost any camera you use these days to shoot video will have a rolling shutter, and that's due to the frequency of CMOS sensors being used in DSLRs and pretty much every smartphone. And you can test this out by pointing your camera outside the window of a moving car and just filming trees and poles that go by. You'll notice that everything that's vertical will be slightly skewed diagonally because the object is moving as it's being scanned from top to bottom or bottom to top. There's definitely pros and cons to both the global and the rolling shutter. For example, the Phantom Flex has a global shutter, which makes it much better for the scientific analysis of shots, as every moment in the frame was taken at the exact same time. The Phantom Flex 4K has a rolling shutter, but it's typically used on movies and TV, where it seems to be quite natural for the human eye to look at. Before I end this video, I feel like I should say a few words about the state of this camera. It's a Canon 7D. I bought it right before I started the Slow-Mo Guys, and I've used it in every single episode to film the real-time segments. And it's taken an absolute pounding. It's been in the splash zone a few times.
Oh man!
Oh, it's right on the lens!
There's a splodge.
It's fallen over. There's a screw loose, I've just noticed. But I refuse to replace it because it still works. So I hope you enjoyed that video. Maybe you learned something. Be sure to follow me on Twitter. I tweet stuff. You can buy a shirt, you can subscribe. Thanks for watching.